Baseline equality is important to address when you're going to make comparisons between two groups of clients. The idea is, if we're going to compare how one intervention compares to another by looking at the outcomes of two groups, we want to make sure they started in about the same place. So we want to make sure there aren't important differences between the groups that might have affected how the intervention impacted each group. So let's say you're a clinician, you're going to compare two groups of clients who get different interventions. You just want to make sure there's nothing like gender or income, education, type of wheelchair they use, whatever, that is significantly different between the two groups. If you're looking at things that are interval or ratio and normally distributed, you're going to use an unpaired t-test. And in this case, the comparison is going to be two-tailed because we don't know which direction we expect. We don't have some prior notion that one group is going to be older than the other or have greater income than the other or whatever we're comparing. So what we're looking for to establish baseline equality is a lack of a statistically significant difference. So if we compare the things that we're interested in and P comes back greater than 0.05, then we can say we've established baseline equality. If we're using ordinal data or we're using interval or ratio data that's not normally distributed, we use the Mann-Whitney U Test to compare the median values between the groups. But otherwise, the logic is the same. We're doing a two-tailed comparison and we're looking for a p-value greater than 0.05. If we've got categories, so we've got ordinal data that we're treating as categories or nominal data, then we're using something called the chi-squared test. Now, in previous lessons, we've talked about the binomial test. That's used for comparisons where we only have two values for the categories, gender or success or failure, whatever it is. Here, we can occasionally have more than two categories. We might break people up into income categories or level of educational attainment, high school, college, postgraduate. And when we've got more than two categories, we need to use the chi-squared test. Otherwise, the same logic applies, and we're looking for a p-value greater than 0.05.